How about now? Can anyone hear me now? Any somebody in the chat, can you throw me a comment in there if you can hear me now? Dave Lewicki, okay, so I got a yes from Paul. I'm heard now. That's good to, okay, we're good to go. Hopefully it won't eat up too much time. I'm having trouble with Excel events today. I wanted to share a slideshow with you of how to make some fiberglass body tubes. Instead, I am going to have to show you some things. Maybe toward the end, I'll try to run that slideshow. The fabrication of fiberglass body tubes, something that I do mainly for competition flying, and I was invited to do this today with an eye toward those of you who want to compete in NRC competition. Now, this has sport rocketry, a regular sport flying applications as well. But the reason that you might be interested in trying this method is that in recent years, when we started the NRC, we moved the motor impulse classes down to some range that would be accessible for most NAR members. So if we were to fly an event like G Eggloft, not everybody has the field size to practice fly that, or to fly that at a regional even. If you're like me and you're out in the desert Southwest with wide open spaces, or if you're in central Kansas like where I grew up, high power events, larger high altitude events, no problem. But for the NRC, we got down into the range of quarter A, half A, and B motors. So we need to get the most performance we can out of those small motors. And to do so, we want to be talking about reducing our weight and also a nice aerodynamically smooth surface finish. So some years ago, my rocket mentor and friend, one of my mentors, George Gassaway, showed me how to make fiberglass FAI models. This is a large size model, about roughly the size of a Big Bertha, right? So they have a minimum diameter of 40 millimeters, which is just 2 millimeters less than BT60. So you're talking about a large model. I was pretty intimidated when it came to making a model that integrated the body and the reducing section and the motor tube all in one. So I chickened out and just made a straight piece of tubing on my FII mandrel. And it worked out well, but it didn't have a lot of use for 40 millimeter tubing. But that year, NARM was coming up and had events that were going to use 13 millimeter motors and Micromax motors. So I started thinking, what if I used fiberglass tubing for myself and for my teammates? I flew competition in team division. What if I made it out of the fiberglass like I did in the FAI models? And what I realized is that I quickly came up with a savings of about 50% of the weight. And we're all used to regular old spiral wound paper tubing, right? This is the good stuff that we've all grown up with. It can be mass produced. It's called craft tubing, to be precise. So here's a couple pieces of brown and white craft, a BT20 or T20 size, and we have the normal T5 or BT5 size. So these are minimum diameter models for most of our A and B motor stuff. If we were to take the good old, this is the Estes Wizard. I misplaced my fin set. I've got a nice light nose cone here. It weighs about 1 gram. I know that my 3 fins, before I misplaced them, my fin set weighed about 1 gram, but this body tube weighs 4 grams. And so if I have my major components together, which weigh 6 grams, but I can replace this body tube with one made from fiberglass and paper in the technique I'm going to show you, I could cut this down to 2 grams. So my overall weight for these parts goes from 6 to 4 total. So I save 30% of the weight right there. Along with Ed LaCroix and George Gassaway, my team members at the time, this is about 10 years ago, started making tubing for them, and I started building models, and they started building models using fiberglass tubing. Here's a couple of NARM winning altitude models. These were for half A and A altitude. This was prior to NRC. These don't have altimeter compartments. but these were the optically tracked. This model is a 1.2 gram for the entire model. This was a little heavier proof of concept model at 1.9 grams. Now, compare this model, NARM winning model at 1.2 grams to this small piece of BT5. This weighs 1.6. So this entire model is a lot lighter than this little piece of tubing. We took that further and decided to look at some of our other designs. This is minus the nose cone. This C streamer model had been it'd been okay. It'd been a contender. Hadn't won at a NARM for us. But at NARM 55 and NARM 56, we converted this for B streamer by replacing the forward section of the body tube with fiberglass, and then this one team event, B streamer, and back-to-back NARMs. So we took 25% of the weight out of the model by going to the fiberglass tube. So I'm here to talk to you about it today in that context for those of you who want to compete in NRC. And I am going to show you a few things in show and tell like I've been doing there. I wanted to show a slideshow, and I don't know that it's going to work. With Excel events, I'm having trouble with it playing nicely with my PowerPoint presentation. The general concept is to find something, we'll call it a mandrel, anything tube shaped. I started out with a piece of brass tube when I first tried this. And then I moved on to steel drill rod stock. And we take our mandrel and we wrap a piece of fiberglass cloth. Now, this is 3/4 ounce fiberglass. Actually, it's 0.7 to 0.6, depending on what the manufacturer advertises it as. You're going to wrap it around your mandrel, saturate it with a laminating epoxy, which is not like a 5-minute structural epoxy from the hardware store. This is a resin made for making fiberglass parts like boats and airplanes. And then with 1 or 2 wraps around here, we're going to try to remove all the excess epoxy. That will leave us with basically a tubular screen door. And so to make a gas seal, I use a model airplane tissue to go over that layer. And then once the epoxy is cured, it's pulled off of the mandrel. I'm going to now attempt to share the slideshow with you. I've based most of my material around that to show you the process. I don't have good internet out in my shop, so I didn't want to do a layup here in the house. The other thing I like to do is use a good respirator or good ventilation whenever I use epoxies or whenever I use solvents and paints. I like to also protect my skin and my work surfaces from any of the drips and drops and whatnot. So if you have questions, put them in the Q&A. I'm probably not going to be able to see the chat, and I'm going to attempt to share my screen with you and share my PowerPoint. And hopefully maybe my buddy Ed or Todd, that one of you guys will text me by phone if I'm not getting through. And so here is my presentation. And I'm hoping that you're seeing this. Here's what I described when it's all put together. I have a steel mandrel. You can see some beads of colored epoxy on there. And then I have the wetted out fiberglass, which looks a little bit like a grid pattern just below that. And then down at the bottom, the yellow tissue over that. So to start out, you need to cut your fiberglass to size. I like to make cardstock patterns and lay a bunch of them out on the table. And Ed's telling me to stop sharing. Okay, I'm going to try that again. Ed's telling me to try sharing my screen. And how about now? Is anybody seeing slides advancing now? So I've shared screen, but not shared the file. So can anyone tell me if they're seeing the slides advance? Dave and Ed are trying to help me by texting me. Anyone? Hopefully they will text me by phone. So I like to make okay. So that's a bust. I don't have a slideshow to show you. What I have then is just the description. And I'm sorry about that. I have no control over Excel events. So we're going to just talk about the materials. When you buy your fiberglass cloth, and I had a list of materials to show you, you're looking for a 0.7 or a 0.5 ounce cloth. And you're going to buy it. I buy mine from either ACP or CST Sales if I'm buying 0.7. What's called 0.5 or 0.56 ounce cloth is generally bought from SIG because it's becoming very hard to find in bulk. So you have to make a choice. You want to cut it 0.90 or do you want to cut it on the bias and drop stuff off the corners? Okay, I have another suggestion to try showing the deck of slides without being in slideshow mode. We're going to give this one more try. And I'm going to share the screen. And actually, I think I killed that PowerPoint. Nope. My apologies, everyone. I have no idea what you're seeing, and I apologize. I'm going to try to click through these slides without going to full slide mode and see if this works any better. So any of the dozen people or so that are texting me, you can try to text me one more time and let me know if that works or doesn't. Basically, to skip through this as quickly as I can, I make patterns out of heavy paper or Bristol board or poster board. I like to lay the fiberglass cloth, which is very delicate, over the top of those patterns and then cut it with a rotary cutter and a straight edge. It's nice to make up a bunch of pieces at one time and then use the paper as a carrier to support the cloth. The cloth will pull out of shape. So I'll lay a bunch of patterns down on my cutting board. And then here's an example of why I say to keep the material on the pattern. It's very easy to pull this lightweight material in a bunch of ways and get little snags in it. So what I like to do is to always wear nitrile gloves or latex gloves. I make up a bunch of pattern sheets, cut the fiberglass to it, and then I can stack them on a shelf or stack them in a drawer. I do the same thing with the tissue paper. I'm buying this lightweight model aircraft tissue, and then because I want it to curl around the form, I store it rolled tightly around a dowel or rolled up in some tissue paper like you see here. And this is what it looks like when it comes off after being stored when I'm ready to do my layups. Got a nice curl to it. And you see this glass tablecloth, that's where I squeegee some epoxy into that paper. So we're gonna go into the setup process. Again, I really recommend you be safe in and around epoxies and solvents of all kinds and glues. So I really mask up. I use a respirator like this, and I cover my hands and protect those with the nitrile gloves. So you'll find a mandrel that's the appropriate size for your body tube, and I have some recommendations for that at the end. And then the one bugaboo in the whole thing is not gluing your tube permanently to the mandrel. So I'm using a spray wax This is crown mold release. This is both the best thing about this process and the worst thing about the process. It's bad on one hand because it has a lot of volatile organics in it, and you really have to do this under a vent hood or outside. You don't want to breathe this stuff at all. A lot of those things quickly flash off, and they leave a beautiful layer of wax on your mandrel so that you can not get your epoxy stuck to it. So I throw my mandrels into a box. You can see the snowy deposit of 10 years worth of mold wax snow in the bottom of that box. I recommend you keep your work area really clean. I'll show you a little flaw later from a tiny bit of balsa dust. I cover my workbench with some brown paper and some plastic, so the following few slides are going to have that brown paper background. You'll need mixing sticks and epoxy cups or something, and then a brush to transfer the epoxy onto that little mandrel tube. I like the 1-inch foam brushes. Any brush that you use with epoxy is going to be disposable. You're not going to be able to clean it out sufficiently for use. So I try to buy the 1-inch foam brushes in bulk and then get them at the lowest cost I can, and then throw them away after each layup. Now, you're not going to be Michelangelo. Trust me on this. You're not going to be painting the Sistine Chapel. You will not be able to drag epoxy back and forth across this fine fiberglass, or the fibers will distort. You'll develop wrinkles and bubbles. All you're going to do is, first of all, paint a line or paint the entire mandrel with a thin layer of epoxy. And once you glue or stick your fiberglass cloth to it, then you're just going to encourage it to lay down by dabbing it with the brush. So I've used these other types of brushes. Always come back to the foam brush because it seems to work really well, and I don't worry about losing little hairs and fibers in my layup. You'll need a way to measure your epoxy. Laminating resins aren't one-to-one like the hardware store epoxies, like your DevCons or your 5-minute epoxies. They're going to mix at a ratio of 1:2 or 1:5, and so there's 3 ways to do that. You can either measure them out by weight using a little scale. You can use a graduated mixing cup to set up your epoxies, or you can use a metered dispenser. And so I've settled recently on using graduated syringes, and I just keep refilling them. As long as you keep your hardener and your resin separate, you can quickly and easily measure 5:1 or 2:1 using different size syringes. So you mix all this up, and the way I was taught originally by my friend George was to mix it up with some dye so that I can see the puddles or the places on my mandrel where I have too much resin or where it's wet, it's extra wet. And the resin's going to add weight. We want just enough resin on there to hold those fibers rigidly in place, because the fibers give us our strength, and the resin's just there to hold it. So these are pellets. Once it's in the mixing cup, like all epoxies, it'll begin to exotherm. And so the warmer it gets, the faster it's going to cure and the less working time you have. I pour it out onto a yogurt lid like you see here in this photo, or I pour it out onto a lid from a margarine tub or something. You'll need a fixture of some sort or a jig to hold your mandrel. This is what I started with all those years ago. I had a 1-foot piece of brass tubing originally, and I made a little holder out of scrap wood. Again, I apologize that these slides are unfinished. I had hoped to do this in presentation mode so you wouldn't see all the title and text box behind there. This is a little bit ugly, I know. Over the years, I found a 12-inch piece on this little tiny holder I could really only get 6 or 8 inches of good tubing out of. And so I went to a 3-foot long holder made out of PVC pipe. And I started buying my drill rod stock in 3-foot long pieces. That was great. By not gluing up the joints on this, I could collapse it and chuck it into a box or a bin for storage. When I thought about introducing this to you this week, I went out into the shop and tried to make as cheap a holder as I could. What I came up with was I threw one together made out of foam core that I bought at a craft store. It's $2 or $3 worth of foam core. It took me about 20 minutes with an X-Acto knife and some yellow wood glue. And I used this. I did 5 layups this past week to try to get myself in the mindset of how I would present this to you. And I'm going to keep it around. I liked it a lot. Now, I'm in Arizona, and I have such dry climate here in the wintertime, and sometimes in the summer we'll get down into the single digits for humidity. And static electricity is a huge problem when dealing with this lightweight fabric. It just likes to wad up. And so George Gasway, when he was teaching me about layups, he would paint a line of epoxy down the mandrel, drape the fiberglass cloth over it and then slowly roll it on as he applied more and more epoxy with the brush from his little palette. I tried that a few times, and with the static electricity and the dry air, as soon as I let go of the cloth, static electricity just grouped it up into a big ball, and I had to wipe the whole thing off and throw it away. What I ended up doing is using some scrap cardboard and foam core and making a little table. So this is me in progress here this past week doing a layup in preparation for this talk. And I used my little foam core holder. I've got this foam core table, which I'm lucky I didn't measure it, but turned out to be the right height. And you can see that I've painted yellow epoxy onto my steel drill rod. And now I'm just carefully rolling and pulling that fiberglass off of the table and onto the rod. And I'm encouraging it to lay down by dabbing, not brushing, but dabbing with my foam brush. A well-saturated brush will just help it lay right down and follow the curve. And once it's all rolled on, then I now have, I can move the table out of the way, but I need to pull off the excess resin. To get it all laid down on there nicely, I'll probably have too much resin on there for a good lightweight product. So to make a lighter, more competitive product, I'll use some toilet paper and kind of dab it. Again, not rubbing, but just dab it on. Here's what a cured piece looks like. You can see that the color in the dye that dyes the epoxy helps me see where it's wet. And I just keep doing this and throwing away the paper until the paper doesn't pull off any more color and until the color looks even across my whole mandrel. Here's the kind of flaw you might get. This is balsa dust. A little grain of balsa dust looks like got on my mandrel and it made a bubble. So I have a delamination between my layers. It's a flaw in the tube. If it's small like this, it's not a big deal. It's not going to affect the strength too much or the aerodynamics too much, but it's to be avoided whenever you can. It'll make life hard for you. There's a couple of tricks. One of them is when I get to that, the tiny overlap of my tissue paper, sometimes the seam doesn't want to lay down totally. I'll cut a piece of cling film and just let the capillary action or surface tension, however you want to think about it, pull that down smoothly. And I can leave that there until the epoxy cures completely and then just pull it off because it's not going to adhere to that cling film. Helps me get away from little wrinkles along the seam. The other thing you can do is if you have a lot of wrinkles or a stubborn one is come up and just touch it with a double-edged razor blade. Usually scalpels and X-Acto knives aren't quite sharp enough, but if you will touch it with that razor blade, you'll get it to slit that and you can make a tiny overlap and it'll lay down nicely for you. There are, every once in a while, you'll get a flaw. The more times you make a tube and the more you stay in practice, the less this happens. I hadn't done tubes in a couple of years, and so I made, 6 tubes over the last week, and one of them ended up with about a 1.5 inch long delamination or bubble in it, and it looks like this. And I'll just have to cut that piece of tubing out. It's probably a weak spot because the paper and the fiberglass aren't held together well, and it's also a rough spot in the airflow, something that I want to avoid. So once it's all laid up, you can clean up your workspace. I mentioned the tissue paper wrap on there. There's 2 ways to think about that or to perform that function. Once you get the glass laid down on there, if you don't pull all the resin out of it, you can lay that curled tissue down carefully and encourage it by patting it down, and it will absorb some tissue and saturate itself. The way to really make a good tube, the way that George showed me, is to use that, you probably saw back in the slide that showed the curled tissue paper, a big glass piece of tabletop. I had found like a 28-inch square glass tabletop on clearance for a couple of dollars, and so I use that, and I'll mix up a couple of drops of clean resin and pour it on that tissue, and then use an old credit card or a gift card and squeegee all the resin from both sides into the tissue so it's completely saturated and clear, and then wipe off all the excess and lay it down. Regardless, once it's done, you just got to set it aside to clear. Now, these are a little bit slower curing resins. If you live in cold climates, you can get away with a shorter cure time by warming it slightly or bringing it into a warm environment. I usually leave things overnight in Arizona. That's usually good enough. I'm usually trying to not get my epoxy to cure too quickly. Once it's cured, it's bonded really tightly to this waxed mandrel. Now's the time to get your surface polish done. So I'll use 4/0 steel wool like you see in the photo, or I'll use some 800 or 1000 grit paper and get a nice polish. I'll get all the rough spots off, and my tube is now externally smooth. Has the advantage of being colored because I used colored tissue paper, and then you got to get it off. So when I first did this, I had short mandrels and I was doing them in the kitchen oven. You heat it up to about 200 to 220 degrees maybe for 20, 25 minutes, depends on your mandrel material. A brass tube allows the heat to get inside, and so it comes up to temperature very quickly. You use a 18 millimeter or 19 millimeter piece of steel drill rod. That's got a lot of thermal mass and it takes a long time to get warm. So with Pat Butler's suggestion, I made a homemade oven. Pat gave me this idea and turned me on to this little electronic controller. Pat originally made an oven out of a footlocker, like a cardboard footlocker, a kid's footlocker, and told me about somebody else who'd made one out of, I believe, an old ice chest. Mine, of course, has a face only a mother could love. This is half sheet of plywood and a bunch of scrap material from around the garage. But I made this oven. With this temperature controller, I can bring it up and hold the temperature at 80 or 90 degrees or 100 degrees Fahrenheit for curing the epoxy. And then when I want to remove my tube from the mandrel, I can crank it up to 200 to 220 and then pull the tube off. There's this nifty little controller made by, I believe it's Ranco, available on Amazon, and it's got its own little temperature probe, and it will control and switch 120 volt appliances. So I threw this little dude on there, found it to be really easy to wire up and hook up. And if we look inside my box, it's basically foil backed insulation as a liner. I got a couple of $2 porcelain light bases or lamp bases bolted to the side in there. $15, probably 120 volt biscuit fan off of Amazon for cooling fan. And then the little black thing you see dangling in from the side is the temperature probe from the controller. So I drilled 4 holes basically, one for each lamp wire, one for the fan wire, and then one for the temperature probe to come through. And this is actually in operation. That's why it's so bright. The heat lamps are heating up my mandrel, and they'll heat it up to a temperature so that I can get my layup off the mandrel. What you'll see is after about 20 to 25 minutes, if you're using a steel mandrel, shorter time again if you're using a tube, which the air can circulate through, the wax will begin to weep, or you'll see droplets appear on your layup. And you do have some micro perforations. Again, we're trying for a gas seal that will hold an ejection charge, but it's not perfectly airtight. And so you'll get a little drip coming through, and that's the signal that the wax is soft enough to remove the layup. What I do is use a nice pair of heavy gloves. Those are gloves dedicated only for layups of different kinds. They're saturated with wax, but you can see the staining on there. This wax gets really hot. I use a couple of paper towels on top of that, and then hold the mandrel with one hand and grasp the layup with the other and slide my tube off. You don't want to twist. You want to just pull and keep it in tension, and it should slide off. Your epoxy, when you put it on, is going to be probably, think of Karo syrup or honey or maple syrup kind of consistency. Well, it's the same thing with the wax. At about 220 degrees, the wax gets to about the same consistency your epoxy was. So it's a viscous fluid. It's not water thin, but it resembles paraffin wax. And I don't know, that may be what's in the material. And you can slide it right off. Then it's time for cleanup. One of the blessings about the wax that I'm showing you here is that it is dissolved very easily using VM and P naphtha. This is the stuff that you can get at the home store or you can get at your hardware store. And it's not too offensive as far as solvents go. It will readily dissolve the wax from your tube and clean it off of your mandrel. So I like to swab down the outside and get all the drips of wax off the outside of the tube with a paper towel, and then use saturated cotton ball or some cotton rope, squirt some naphtha in there, and then ramrod it back and forth through with a thin dowel to clean out the inside of the tube. And then sometimes I'll let it dry off, let the VMP naphtha, let the naphtha evaporate off, and then I'll see if it still feels waxy on the outside. And sometimes I'll give a final external wipe down with a little bit on a paper towel. And then your tube is ready to use. It can be trimmed to length. It will take CA and epoxy really well for bonding fins. The naphtha is great for cleaning out the spray nozzle because it dissolves so readily, the dried wax. So if the spray nozzle on the can gets gummed up, you can just kind of get that out. The sizes I recommend, don't go 13 millimeters for your drill rod stock if you want to make BT5 style tubing. I did it and I regretted it. If you have really, really old Estes motors from the 1960s and 70s, maybe even early 80s, and they've been kept really dry, they will fit a 13 millimeter tube. But as soon as you open the box or bag that you've stored them in some green verdant place like Great Meadow in Virginia or a flying field in Ohio or a Narrum in Michigan, those motors will begin drinking water out of the air like you wouldn't believe, and will begin swelling, and they will no longer fit your 13 millimeter tube. So the size you want that will fit BT5 size nose cones, centering rings, couplers, and your mini motors is you want the standard size drill rod in 0.5156 from McMaster Carr. That size works beautifully. Now for the standard size motors, the BT20 size, you want 18 millimeter drill rod stock, and it is available in 1 foot and 3 foot lengths. So that's where I get that. They also have a bunch of other sizes. So if you want custom tubing, you want some 14 millimeter to be a slip fit over the outside of BT5, you can get that. I have it and I use it. If you want 19 millimeter tubing, which will slip fit over the outside of BT20, they sell that, and I have it and I use it and it's great. Again, the blessing and curse of the release wax is the mold release, only available in case quantities. And unfortunately, when I'm introducing to some of you who may not have tried this technique, this is the worst thing. You have to buy a case of it or split a case with a friend, which is what happened. Ed LaCroix, my teammate, was kind enough to split the first case with me, and so I didn't have to choke down that whole cost myself. Cans do several layups, so you're getting a lot in there, but it's just, unfortunately, I'm a cheap rocketeer like everybody else. I want to get the most for the least amount of money, and I find that to be the difficult part. As far as finding the glass, I started to skip ahead to that when I wasn't getting these up here. ACP Composites, they make the nice line of Easy Lam resins. Those are a 1-to-2 mix, and they also sell an excellent epoxy dye. Colors like red and yellow are the ones I normally use. If you want to really get lightweight glass, like I said, ACP and CST sales will sell you the 0.7 or 3/4 ounce glass. If you want to get that 1/2 ounce glass, it's going to come from SIG Manufacturing, and it's always going to be folded. SIG sells it in 2-yard and 5-yard packages. I also use West System resin from time to time. Their complete line of resins and fillers are great for a number of rocket and model airplane applications. Their technical info is at westsystem.com, and you can find a local distributor from there. For me, that local distributor is West Marine. There's a couple stores here locally, and I can just go over and buy their products off the shelf. Again, this is kind of what it looks like. The roll at the top, I actually find CST will once in a while have this desirable fiberglass on sale in odd sizes. And so I bought like a 14-inch wide by 50-foot long roll for a few dollars some years ago. The larger folded up package you see here is the way ACP ships their fiberglass. If you buy just a couple yards, they'll roll it if you buy more than 5 yards. But the SIG glass that's in the Ziploc over to the side there, that's a 3/4 ounce sample, but that's how they fold up their 1/2 ounce glass too. And so if you really want to shave every last 1/10 of a gram out of your model and you really want to use the 1/2 ounce glass, you'll probably only be able to find it at a local hobby store or from a SIG retailer online. And it will unfortunately be folded, which means somebody else has already handled it to fold it up, and you have to handle it again to unfold it. So there's always that handling which distorts the glass fibers a little bit. Talked about the resins. There's the West System. It's a 5-to-1 2-part. And the nice thing there is you can choose hardeners of different speeds. If you live in a warm climate like me, you'll want the 206 hardener or slower. If you live in a cooler climate, you can probably get away with the 205 hardener, which is also very nice. But they're both 5-to-1 mix regardless. Easy Lam, I'm about out of. My hardener bottle's gone, but we have the ACP. That yellow bottle is the dye that I use. It works very nice and works well with Easy Lam. I have dyed some of my epoxies using Alumilite. This is a dye made for their resin molding stuff. It's available at Hobby Lobby. It doesn't have a long shelf life once opened, but I've tried fluorescent dyes, which make a cool fluorescent tube with the dye in. I don't know how it affects the strength of my epoxies. I have not had trouble with it, but it's something you might want to play with. I've used this black along with black tissue or blue tissue to make a deep black tubing or a midnight blue that comes out quite nicely. The tissue paper that I originally started using was what was referred to as Jap tissue or Japanese tissue. That was a slang term for a tissue made by Esaki. Super lightweight tissue. If you've ever built a boost glider back in the old days, you might have doped that tissue onto a solid balsa surface to add strength and color. And that was primarily what I used when building my FAI models and making the lightest bits of tubing that I've made. About 2 years ago, Esaki either went out of business or just decided to quit producing that tissue line and is no longer available. Other tissues I'd used were PEC Polymers domestically made tissue, which was also colorful and color stable, but just a little bit heavier and thicker. PEC Polymers has since been bought by a company called Wind It Up. They bought a number of small cottage industries and model aviation. And so they carry a domestic tissue now. And so that I could honestly recommend products to you, I went out and bought all 3 samples of tissue that are listed here and did layups over the last week. I didn't want to talk to you about something that was unobtainium and show you layups, because a lot of these layups, like the super lightweight little altitude model, that uses Japanese tissue, the old Esaki tissue. So EasyBuilt Models is online, and they import a Japanese tissue called Mount Fuji tissue. It is a little more expensive, as you can see, but it is a great replacement for the old school Japanese or Esaki tissue. EasyBuilt's domestic tissue is almost identical in weight and handling characteristics to the PEC or winded up tissue, but they sell it in twice the size sheet. It's about $1 a sheet. Half that size sheet you can get from PEC or a winded up in more colors, but about 50 cents a sheet for a 15 by 20. And so, of course, that tissue size is going to determine whether or not you want a single sheet of tissue for your layup, or if you want to have to splice it together for a multicolored tube, which I have done, and it works very nicely as well. A final note, when it comes to the toilet paper, you're going to remove the excess resin from your layup. You want the worst toilet paper in the world. You want the stuff from the airport or the truck stop out on the interstate. You want the big, non-perforated, maybe even single ply stuff. You don't want cushy stuff like you'd use at home, because you don't want something that's soft and going to shed fibers. Some of the Cottonelles or Charmins or whatever other name brands that you find in the store, that the high-end, really nice toilet paper will leave fuzzy bits of paper fiber in your layup and make it almost impossible to lay your tissue over. You'll have all kinds of bubbles and checks. So you want to find the bad stuff. I don't remember, it might have been Ed LaCroix or somebody gave me this industrial roll of non-perforated tissue. And this is awesome because I can just cut or tear off 2 or 3 foot lengths of it and have a pile of it laying at the end of my work table. And then I can do my layups. One last picture, actually, I'm going to skip that and stop sharing. I'm going to try to get to your Q&As, and I'm going to try to do a little bit more of the show and tell here real quick. Now, I was really intimidated by trying this process. I didn't want to spend a bunch of material or a bunch of money buying materials that I might screw up. So what I did when I first did it, and I do this to this day, just to encourage you as a newbie, if I go to make, and I apologize, I realize the lighting here has changed and I'm in the dark. When I go to make my first layup, I make a firm one. I mean, these are tubes that are just rock hard. I throw a bunch of layers on my mandrel, I let it cure, I pull it off, and I get a successful layup. I do this with my small ones, I do it with my big ones to get myself over the intimidation factor. Now, what I do is use that heavy tubing to make tooling. So I made, Ed LaCroix, I think, made most of these. I made one of them. And these are plug cutters made from that heavy tube. So to get rid of my case of nerves when it comes to making a tube for the first time in a new size, I throw a bunch of layers. I maybe use heavier cloth than my lightweight stuff, and I make a plug cutter. And then I can make custom foam ejection plugs in various sizes for my competition models. And so I don't waste that heavy tube, but I get it out from, I get the nervousness over of trying to make a tube. I don't think I showed it well at the beginning because I was a little flustered with the technical difficulties. So this tubing, this is the 18 millimeter rod. It fits BT20 nose cones really well. It's going to fit your cool composite motors. It's going to fit your standard Estes motors. That 0.5156 or whatever it was drill rod stock, that also fits BT5 size nose cones, fits the MIDI motors perfectly, and also that means it fits all the couplers and all of the other things, motor blocks and everything else. So I'm going to try to answer questions now, and we'll go through these. So from the bottom, let's see, thank you for confirming that. Somebody confirmed that they could see that. Robert Zurich said, how does the weight of the fiberglass tubes compare to rolled vellum? I don't know. I've never done rolled vellum. I think they're a little heavier than rolled vellum. I know my teammate Ed had made competitive models in rolled vellum, and I think that rolled vellum was even a little lighter. But the thing you don't have to worry about with these is any resistance to dew on the grass, humidity. You don't have to worry about this. This is a waterproof tube. Rolled vellum is even more susceptible to humidity and water than the craft paper tube. And it seems like to me, my NARM flights are always happening on a wet, rainy day, or else I'm landing my model in dewy grass or corn, right? Head-high corn. So there's that. Guy asked, what's the approximate fiberglass mill thickness? Ooh, that's a great idea. I don't know. I know it's thinner than this. I should have measured that, and I don't have my calipers with me right now. I apologize. I think it's, I want to say it's, I don't know, 5 thou maybe? I'm not sure, but it's thin. If I have a piece of BT20 and I have my 19 millimeter tube, it fits really well over it. But if I put my 19 millimeter tube over my 18 millimeter tube, it's sloppy. Okay, so that gives you an idea. I think it's pretty thin compared to paper or the craft tubing. So I hope that helps you a bit. I don't know exactly. Let's see, Jay Marsh, do I spray the light fiberglass with hairspray? You know, Jay, I haven't tried that. I've heard other people do that, and I saw Tim Van Milligan kind of did a sizing with like a light spray of fiberglass of fluorescent paint. I haven't tried that, and so I don't know if that would work. I don't, and I probably could try that because I think the wax in the fiberglass paint, or I'm sorry, the wax in the hairspray might not disturb the layup too much. I don't know, and if you've tried that, maybe that's something I should try too, but I have not tried that. Kevin, do you get my glass cloth in variations of thread weights, different warp and weft thread counts? I don't really pay attention to that the way I would for a high power layup or for like a model airplane application for strength. Generally, these light weights are only available, as far as I'm aware, in just a plain weave. So it's just 3060, or I'm sorry, 090 plain weave cloth with no twills or satins or anything like that. And I don't know about thread counts or anything like that. I know that these are generally a surface layer. So if you're making a boat or you're making an airplane wing, you put your coarse layers of fiberglass down, and then you put this fine fiberglass on top, and then you vacuum bag the thing or force it all into a mold. And this helps hide all of the thicker weave, rougher weave underneath. So I'm using what is designed as a finish layer as my structural layer. Glenn asked, how many coats of mold release? I'm sorry, I didn't say that clearly. 3 to 4. You'll have to kind of play with that, and you want to wait about 5 minutes between coats. So if I have my mandrel in the holder and I spray it, I'll turn it, spray it. I probably 7 or 8 or 6 or 8 turns as I spray, and then walk away. I don't hose it on. I'm going to spray it like we're spraying spray paint. I want a nice even coat. I spray down, turn, spray down, turn, and then when I get it all the way around the tube one time, I walk away. Now, I like to lay a guideline down my tube for laying on my fiberglass, what I do is before I spray my mandrel, I use a straight edge like I would marking fin lines on a body tube, and use either aluminum channel or angle, and just make a Sharpie line right down the tube, right? And then I can see where I am when I'm turning it, spraying the wax on, because the wax goes on clear. And also it gives me a guideline to start my fiberglass and my tissue paper when I am laying it on the mandrel. Actually, nowadays I use two guidelines. I use a red one on one side and a black one on the other. And I start my fiberglass on the black, and I start my tissue on the red, so that the seams are on opposite sides of the tube from each other. It's not important, that's just the way I do it. It works just fine with all your layers stacked up and overlapping at the same point. Paul asked, to avoid the smelly mold release spray, have you ever tried using some sort of hard wax? I have, and it didn't work for me. Tim Van Milligan did a great talk a few years ago at NARCON about a really involved process he had for making the FAI body tubes, right? The ones that incorporate the body and the transition and the motor tube and all that. And he used a Teflon coated like paste wax, and I have tried it. I have not had good results with it, and I don't know if it's my technique or the wax I got. Trying to break loose my layup from the wax, I ended up either tearing the layup apart, because these are fairly thin, or I just rubbed all the skin off my fingers and I had blisters for days. So I don't do it anymore. I may try it again in the future, but those paste waxes, I've heard they're the way to go, but I have not had good luck with them. Here's an example. I was talking about you can make a multicolored tube. So this was when I got back into this last week preparing for this. I found scraps of tissue and just a scrap of cloth, and did a nice BT5 body tube in 2-color. So I just laid those pieces of tissue right next to each other as I rolled them on, or rolled them on separately. So Paul, I hope that answers. I have not been able to have any success with those. I know other people use them. Harlem, when cutting the fiberglass sheet, would you cut it to be the exact size as the circumference, or do you want a little larger? Yeah, I didn't talk about that very much. I like a few millimeters of overlap. I'm not a machine, and I can't get it on perfectly. So most of my body tubes are 2 layers of glass. So I'm taking the circumference times 2 and adding a few millimeters for overlap. And then my tissue paper is a single wrap. So it's the circumference times 1 plus a few millimeters of overlap. Now, if I want to get really competitive and go to a world championships, like some of my FII models, or this super light altitude model, this was a single wrap of glass with this little overlap, and a single wrap of the lightest tissue I could find to make, the body tube on this actually is weighed out at less than 1 gram for the body tube portion. So that is a great thing. Yeah, you do want a little overlap. It's really hard to edge match perfectly, and you want those fibers to overlap a little bit for strength. So thanks for asking that question. Robert Zurich, do I polish the mandrel before use? Yes, and I got started off on a rough spot with my tech. What I do with my mandrel is I start and make sure there's no rough spots. I steel wool it if there's any rough spots or any burrs on it. Then I'm going to wipe it down with naphtha or mineral spirits or something to clean anything off of it before and then I'm going to draw that guideline with a Sharpie before I do it. But my prep, I inspect my mandrel really well before I do a layup. I don't want lumps of old epoxy. I don't want crusty gunk on here. I want it to be nice and smooth from end to end. And so steel wool, and then a good wipe down with, I just use the naphtha since it dissolves my wax. I know it's going to clean my old wax off. And so I give it a quick polish down with the naphtha. If I feel any gritty spots, then I'll hit it with steel wool and then touch it up again. So thanks, Robert. I'm glad you asked that. Ed, don't worry about starting late. Okay, thanks, Ed. I appreciate that. Hopefully you'll see Max asks, will there be the same process that you showed us also for carbon fiber? So Max, I don't know that. I tried doing this out of carbon fiber tissue, which is kind of, unlike a woven cloth, it's like a random direction carbon fiber. And because I'm not pulling a vacuum and I'm doing this at atmospheric pressure and I'm not bagging this and pressing it down, I ended up with a body tube that was like a graham cracker. The carbon didn't lay down as well as the fiberglass did. And so I don't know if it would work in other ways. If I had a way to vacuum bag this or do one of the really complex molds like Tim Van Milligan's been working on at Apogee, or any of the FAI flyers or competition flyers know Kevin Kuchek. He made an amazing mold for his stuff. You could use carbon fiber in those ways. The only way I know to incorporate carbon fiber in this right now is by using a few fibers. So I could add stiffness longitudinally, and I've seen people do that. They get the straight, I don't know what that stuff's called, toe or whatever, and lay down a few fibers. But I don't know that it would work as well with carbon fiber. Jim Filler, how much pigment? Oh, I didn't say that. I use for a 6 gram or so, or 12 gram mix of epoxy, the piece of pigment, the little dab in there is only about the size of a grain of rice or a little smaller. So I don't actually measure it. I kind of go by eye, and I stir it in really well because I want a consistent color through my epoxy blob. And if it looks like it's too pale, I might throw some extra in. This is actually a fiber. I don't know if it shows up well on the camera. This is fluorescent dye using a few drops of the Alumilite and actually made a fluorescent tube. Now I made a few extra wraps on this. This was for tooling, but it's super stiff. For the sport modeler, making a stiff tube might be cool for the new higher thrust, or if you have the old Aerotech D21s, but the new Q-Jet motors may be really cool to use. I'll just touch on this before I leave. This is a stiff tube. I mean, this thing is really stout. It weighs at or below BT20 weight, but this is 2 wraps on the bias with a single wrap on the 090. So it's got 3 layers of fiberglass, and then it's tissued over. This is the kind of thing I want to jackhammer with like an 18 millimeter E motor or something, because it can really take it. And so it weighs the same as paper tubing, but it's just really heckin' stiff. I really like it. So yeah, I got off subject there, but Jim, that's a great question. Again, I just like grain of rice or smaller size little blob of dye. A little dab does you. I mean, it lasts for years. Sarah Jackson asked to reiterate the process. Yeah, first mold release. Then what I prefer is epoxy. Some people, like I said, George, he would paint a line of epoxy and then just add epoxy as he rolled his material on there. I like to just paint epoxy on and then roll my fiberglass in and encourage it to lay down in that wetted out epoxy on my mandrel with my foam brush. And I keep saturating the brush. You want a wet brush. And then El Cheapo toilet paper to get the excess epoxy out, and then I put tissue paper on. I've done it both ways. I put it on dry or pre-saturate it with my resin, and then you're correct. I cure it and then heat it up to release it. So the tubes are actually fiberglass foundation, tissue paper coating. You're correct, Sarah, and that's done as a gas seal. I actually have one here that I did without the glass just to see how porous it is. And I really can't show this to you, but if I plug one in and blow on it, I can feel 1,000 little jets of air leaking out of this tube. I think an Estes ejection charge would clear my recovery system out of this, but it might be dicey. I think that it pressurizes the tube fast enough that we get out, but that tissue layer is just a seal on the outside of that. So she asked, the tissue paper is not necessarily more strength, it's for a gas seal. Tissue doesn't add a whole lot of strength to it. It does add some, but not so much as it is there for just a gas seal. Sarah, thanks for asking that question. Ed Jackson, I tried spiral wrap with 50% overlap. I haven't, just because I don't want more seams. The nice thing about laying up these tubes straight is that I have one seam, and while it's on the mandrel, before I release it, I can get in there with a sanding block with some really fine sandpaper like 600 or 800 or 1000 grit, and I can get that seam to almost go away. And by spiraling it, I fear that I would have just more things to sand down and break up that transition. So I want not only a lightweight tube for high performance in the NRC, but I also want a nice smooth surface. This is like really smooth. It's not glossy, glassy smooth, but it's really smooth. So I don't try to spiral wrap anything. Taras, after the release agent's dried, prior to laying fiberglass, do you polish smooth? I don't. Taras, it's great to hear from you, man. I'd love to see you. It's been a couple of years. It doesn't get much of an orange peel. Yes, I'm splattering wax on there by spraying on the wax, but it goes down really smoothly. And the inside of these tubes is super smooth. I don't polish that wax. You can scrape it off if you're not careful when you handle it. I mean, you can leave a sprayed mandrel once it's got 3 or 4 layers of wax on it. You can leave it around for quite some time in your shop before you get around to doing your layup. But if you ding it up, you can actually chip that wax off the mandrel, and then you'd have to completely strip it and recoat it, I think, in order to do a good layup and not risk bonding it to that. I think I've answered all the questions, and I thank everyone who attended today. I hope that you got something out of it. I know I ran kind of long. I see David Kane includes a link in there from Hobbyco. That might be interesting. Some glass there that's nice and light. If you can find that stuff, that's great. Again, it looks like it might come folded up in a package, and that would mean extra handling. I know there's another talk that's going to go on. If anybody else wants to throw anything in the Q&A, I'm happy to continue answering questions in the Q&A until nobody else is in there. But appreciate it. It was fun for me giving this. I'm sorry if we went a little slow. Let's see, I think another question came in. Oh, you're welcome, Taras Tatarian. Have a great one. Have a good day. And well, that's it. That's all I've got. Have a good day.